Dear students, now I am going to explain bipolar junction transistor. In short form, it is represented by BJT. That first letters they combined and they have given the short name for that, BJT. So bipolar junction transistor. So in this video, we are going to discuss introduction, okay, and then definition, types of transistor, types of BJT and how it is constructed, and then formation of depletion region, and then biasing the transistor, how the transistor is biased. So this part only we are going to discuss one by one. So let us start the introduction part. Okay, so let us go to the next page and start the introduction for that. So what that means, who discovered this BJT? Okay, the first point is bipolar junction transistor was developed by Dr. Shockley. Dr. Shockley, Dr. Shockley with his team in Bell Laboratories. In Bell Laboratories in the year of 1951. Okay, so who discovered? Dr. Shockley with his team in Bell Laboratories in the year of 1951. Okay, so what is that? Where it is used? Okay, this is the transistor is the main building block. Main building block for all electronic devices. Okay, all electronic systems. So this is the main building block for all modern electronic systems. Modern electronic systems. Electronic systems. So this transistor is the main building block, right? And the next one is, it is a three-terminal device. Three-terminal device. How many terminals will be there? Three-terminal device. So in this videos we have discussed about PN junction diode. It is a two-terminal device, but the transistor is a three-terminal device. Okay, this whose output, okay, the output of this transistor, whose output current or output current, voltage and power. Okay, output current, voltage and power. Three component, three things. One is current and another one is voltage and power are controlled by, this is very important, are controlled by the input current, are controlled by the input current. Input current. Listen carefully. The transistor is here three-terminal device. Here three terminals are there. This out, that means the output of this transistor, which is current, voltage and power, all are controlled by the input current. All are controlled by the input current. Okay, and then mainly, that means where the transistor is used, mainly it is used in communication system. Where it is used? In communication system, especially as a amplifier. Communication system as an amplifier. Transistor is used as an amplifier. So now you will have the doubt, what is mean by amplifier? So amplifier is a circuit that is used to increase the strength of the AC circuit. Okay, for example, amplifier means it increases the strength of, it increases the strength of an AC signal. That is very important. An AC signal. AC signal. So for example, if you are talking in the mic, okay, in speaker, how it is amplified. So in between the mic and the speaker, one amplifier system will be there that will increase the strength of the voice signal, audio signal. So that is the function of the amplifier. Okay, so mainly in communication system, this transistor is used as an amplifier. So what is meant by amplifier? Amplifier means it is the device which increases the strength of the AC signal, increases the strength of the AC signal. Apart from this, that means a transistor are used in digital computers, digital computers, in mobile phones, digital computers, mobile phones, satellites, satellites, in communication system, control system, etc. In all the places, this transistor is used. So these are the small introduction part I have given to understand what a transistor is and where it is used, so that you will get the interest towards the topic. Okay, so now introduction part is over. So next we have to discuss about what is the definition for transistor. What is the definition for transistor? So the next step is we have to discuss the definition for the transistor. So already I said it is a three terminal device. So let me write the definition first and then I will explain. A transistor is a semiconductor device consisting of three regions separated by two p-n junctions. Okay, so this is the definition to understand what a transistor is. So a transistor is a semiconductor device, and which consists of three regions. Okay, three regions which are separated by two p-n junctions. Okay, so already we have idea about diode. So diode is nothing but p-n junction. Diode is nothing but p-n junction, only one junction. Now you see what is a diode p-n junction. The center part is the junction. So two terminals are there here. This is one terminal, this is the another terminal. The two terminals which are separated by one junction, one p-n junction is the diode. But a transistor means three regions separated by two junctions. That will be the difference between the diode and the transistor. Okay, so now you have idea about the definition part. So how can we explain this? Okay, so for that I am going to discuss the types of the semiconductors. Okay, transistor means you have the idea. So what are the types of transistor? There are two types of transistors available. They are, first one is NPN transistor and the second one is PNP transistor. The first one is NPN and the second one is PNP. So let me draw the small symbol to represent how it consists of three regions and two junctions. Now you see three. Okay, first region is N, second region is P, third region is N again. Okay, so see the second one also, three regions. The first one is P, the second one is N, and the third one is P. So now you can understand it consists of three regions and three terminals. Okay, so first terminal, second terminal, and then third terminal. So now you see three regions I mentioned: first region, second region, third region, and the three terminals also I mentioned already. So this is the now you see first terminal, second terminal, third terminal, right? And then see here. So this is one junction. So first PN junction, already one is there. Okay. And this is the another junction. So this is another PN junction. So we can call it as junction J1. Okay. This is junction J2. So two junctions are there. Now you see the definition. Three regions, okay, already three regions, and I mentioned already three terminals. So 1 2 3, and then two separated by two p-n junction. So separated by two p-n junction, so that you can understand the definition clearly. So a transistor is a semiconductor device consisting of three regions separated by two p-n junctions. And moreover, we have discussed the types of transistor. One is NPN and another one is PNP. Okay, so now in this case, how NPN transistor is formed? They have taken two, that means three semiconductors, N, P and N. Okay, so what they have done, in between the two N regions, they sandwiched this P. Okay, in between these two N, they included the P. For the second case, in between the two P-type semiconductors, they included N. So that they formed the transistors. Okay, so this is what the types of transistor. So the next, now definition is over, next types of transistor over. So next we are going to discuss about the construction of transistor, how the transistor is constructed. So now construction of transistor. So to explain this transistor, I am going, that means construction of transistor, I am going to consider NPN transistor. Okay, with the help of this NPN transistor, I am going to explain the construction part. Okay, so now already I mentioned three terminals are there. Okay, how many terminals? Three terminals. So now this is N and this is P and this is N again. Okay, so this is the first terminal and this is the second terminal and this is the third terminal. Okay, so now I'm going to give some special names for all the terminals. So the first terminal is named it as emitter. The first terminal is emitter and the second terminal is named it as base. Second terminal is base and the third terminal is called collector. Third terminal is called collector. So three different names I have given for the three terminals. The first terminal is named it as emitter. The in between part, that is the central region of the transistor, is named it as base, and the outer part, that means the last region, third region, is called the collector. Okay, so let us discuss these three terminals in detail one by one. So first one, emitter. So from the name we can understand very clearly the emitter is the part, okay, it will provide the charge carriers in large numbers. Okay, its duty is to emit large number of charge carriers. So in case of NP, now the emitter is N. The emitter is N in this case, especially for this case, the emitter is N type. So N type means it produces large number of electrons. Okay, if we consider PNP transistor, in that case emitter will be P type. So its duty is to produce large number of holes. Okay, but in whatever we have considered, that is NPN, so for that it produces large number of electrons. So commonly we can consider it as large number of charge carriers. So what is the main function of emitter? To provide large number of large number of charge carriers. Large number of charge carriers. So if it is NPN, we can mention electrons. If it is PNP, we can mention it as holes. Okay, so that is the main function of emitter. So the main fact is it has to produce large number of charge carriers so that it should be heavily doped, then only it is possible. Okay, it should be heavily doped. What is the meaning of doping? Doping means adding impurities to the semiconductors. So to produce that n-type semiconductor means we have to add the pentavalent impurities like phosphorus, arsenic, antimony, bismuth, etc. So any one kind of pentavalent impurity is added heavily to produce this n-type as a emitter so that it will produce large number of charge carriers. So these are the two things you have to understand very much clearly about the emitter. Okay, and then the size of the emitter in the transistor, that is also important. Okay, so that it will be in moderate size comparatively with base and collector, its size will be moderate. The size will be moderate. So these are the 3 points you have to remember to understand the emitter. Okay, so emitter's duty is to provide the large number of charge carriers. To provide this, it should be heavily doped and then it occupies moderate size in the transistor. Okay. Next, we are coming to the base, the second region or the center part of the transistor. So now the base, what is the use of the base? What it is going to do? The base actually it passes the charge carriers from emitter to collector. Its duty is to pass, only it should act as a control. Okay, it should pass the charge carriers from emitter to collector. That is the main function. So I can write here, it passes the charge carriers it passes the charge carriers from emitter to collector. Emitter to collector. This is the main function. Okay. So already I said its duty is to pass only the charge carriers from emitter to collector, so that it should be very lightly doped. Okay. So that it should be very lightly doped. Very small amount of impurities is added. Here it is p-type. In this case the base is p-type. So base is p-type means it is the p-type semiconductor. So the majority charge carriers are whole. So in this case the whole will be very less in number due to the lightly doped. Okay. And then the main thing is it should be very thin in size. Its size will be very thin. It occupies very thin area in the transistor. Okay. And the main part is it acts as the control. Okay. It acts as a control on the flow of charge carriers from emitter to collector. Okay. Mainly the base acts as a control on the flow of charge carriers. The flow of charge carriers from emitter to collector. Emitter to collector. This is the main part here. Okay, emitter to collector. What is the control? So that let me give one small example. Take one water pipe. Okay, so this is the water pipe. Okay, this is the water pipe. So this will be this is the water pipe. So this is the input. Okay, from here we are going to apply the water, and then here we are going to collect the water. So this part will be the emitter. Okay, it is going to emit the water, and here we are going to collect the water, so that it is the collector, right? So this is the emitter part and this is the collector part. Now you see how the water should be controlled. So who is responsible to control the water? I have to stop the water. I want to get the water. So who is going to control? The tap. Who is going to control this? The tap. Okay, so the tap is nothing but base here. The tap is, that means if I want the water, I can adjust the tap to get more water. If I don't want the water, then I can stop the tap. Okay, so this is the control of the water. So that is what base here. So the base is act as a control on the flow of charge carriers from emitter to collector. So now you will get the clear idea about what is the function of the base. So it can able to control the flow of charge carriers from emitter to collector, right? So this is the main function, right? So now what are the things we have discussed? Base is passing the charge carriers from emitter to collector, and it is its duty only to pass from here to here, so that it should be very lightly doped, and it occupies very small region in the transistor, and moreover it acts as a control on the flow of charge carriers from emitter to collector. Okay, so next, the third part, the final part is the collector. So from the name we can understand very clearly the collector is nothing but going to collect the charge carriers from emitter. Okay, so it collects the charge carriers. It collects the charge carriers from the base. So through base only the charge carriers will come. That's what I mentioned here, from the base. It collects the charge carriers from the base. And moreover, its duty is only to collect. It is not going to produce anything else. Okay, that's what it is, moderately doped. Okay, moderately doped. So when we compare with the emitter, it is heavily doped to produce large number of charge carriers, and it is lightly doped. Its duty is only to pass, and it is moderately doped. Okay, that will be the difference. And the third point is it occupies more space in the transistor. So it is large in size. Large in size. So here it is very thin size, right? But here the collector should be in larger in size. Okay, why? Because it has to collect more amount of charge carriers. That is the reason it should be larger in size. Larger in size. So this is what the function of the collector. So I hope you understand what is that three parts, three regions in the transistor. One is emitter, and another one is base, and the third one is collector. Mainly how the base is acting, for that I have given one small example also, so that you can understand the function of the base in between the emitter and the collector. So here now I have taken the example of NPN. So the N region contains free electrons. Okay, here N type is electrons are the majority charge carriers in the N type. So it will have large number of electrons. So that the electron should pass through this P type and then finally it reach the collector. So it produces the large amount of electrons here, large amount of current. Okay, so the working part in separate video we can discuss how the NPN and the PNP transistors are working, but now I just given the explanation for the construction of transistor with the help of this NPN transistor. Right, I hope you understand this part. Let us move to the symbolic representation of the transistor in the circuit. The next one is how it is represented in the circuits. Okay, symbolic representation or schematic representation. Schematic representation of transistor in the circuits. We are going to discuss about the NPN and PNP both. Okay, so first let me consider NPN. Okay, so already we have drawn one diagram. The same diagram I am going to repeat here. Same diagram. Now you see three regions it consists of. So N is moderately size, that means moderate size it occupies, and the P should be thin enough. Okay, and then this part, the collector part, will be larger in size. Okay, so this is emitter, and this is base, and this is collector. All right, the same diagram I am going to draw in the vertical direction. So how can the same thing? Okay, this is in horizontal direction. I am going to draw in the vertical direction. So now you see, all right. So here this is the emitter part, this is the emitter part, and then P, it is smaller in size. Okay, and then this is N. So this is base, and this is collector. So here two junctions are there. I am going to give the name for this junction. Now you see emitter and base. This junction existing between the emitter and the base, that's what it is called EB junction, emitter base junction. Emitter base junction. Okay, generally it is represented by J1, emitter base junction. Next junction here it is existing in between the collector and the base. Okay, so that it is represented by CB junction, collector base junction, that is CB junction. So which is represented as J2, which is represented as J2, right? So next, how it is represented in the circuits, how it should be represented in the circuits. So they'll take one circle, and then here, so three terminals. Okay, three terminals they have mentioned, they will mention like this. Now you see three terminals are there, right? So now the down one is emitter, the down one is emitter, the center part is base, the upper part is collector. Okay, so this is what, and then here they will represent the arrow mark, they will represent the arrow mark. So for NPN transistor, the arrow mark will be like this, the arrow mark will be like this. That means the current to flow from B to E. The B is in this case, especially for this case, base is P. Okay, this is the P region, and this is the N region. P region, and this is the N region. Emitter is the N region. So now listen, the current flow will be in the direction of P region to the N region. That's what the arrow mark will be like this. So by seeing this arrow mark only, you have to identify this is the NPN transistor. Okay, so P to N. So it is coming towards N, so that we can identify it is, this is N means here it will be P and here it will be N. So that you have to identify NPN transistor. Okay, so always you remember the direction of the flow of current towards N region, so that easily you can identify, right? So this is the schematic representation of NPN transistor, especially for NPN transistor. The same thing we are going to discuss for PNP transistor also. Okay, so PNP. So what is the diagram for us? This is the horizontal direction. So first one is the emitter, moderate size. The second one is the base, very smaller in size. And third one is the collector, which is bigger in size. So emitter, base, and then collector, right? This is base. Okay, the same thing I'm going to draw in the vertical direction. So emitter will come down. Okay, this is emitter P, and then base is smaller in size N, and then this is P. So the upper part is the collector, and the second part, the center part is the base, and the lower part is the emitter, right? So same diagram, how can we draw? The transistor diagram, we have to draw the circle. Okay, right? So now I am going to mention the three terminals, the terminal base, this is the base, and this is the emitter, and this is the collector, right? So already I mentioned the current to flow from P to N. Okay, so P to N. So in this case, what will happen? N is at the center, base is the N region. So this is N region, right? So the current flow from P to N. So here they will mention the arrow mark like this. So this is means here it will be P, and this is also P. So this, by seeing this diagram, you have to identify the that means the flow of current is towards base. So base should be N enough, so that PNP transistor. So by seeing the arrow mark, you have to identify which type of transistor is included in the circuit. Okay, so towards N you have to remember the current flow towards N. That means the direction of the flow of current in the circuit. So this direction represents the flow of current in the circuit. So from this you can understand how the transistor should be identified by means of the arrow mark. Is it clear? Okay. So next we are going to discuss about how this depletion region will be formed in case of the bipolar junction transistor. That is the next topic we are going to discuss. Formation of depletion region. Formation of depletion region. So for single PN junction, how the depletion region will be formed, already we know that. But here two junctions are there. Okay. For that two junctions, how the depletion region will be formed. So already we have discussed emitter is heavily doped. Emitter is heavily doped. And then base is lightly doped. Base is lightly doped. And the third one, collector, is moderately doped. So as these three regions are doped in different levels, doping is in different level. It is heavily doped, it is lightly doped, and this third one is moderately doped. So due to this different doping levels in three regions, okay, the depletion regions will have different width. The size of the depletion region formation will be have different size, different width. Okay, so that part only we are going to discuss. Now you see, I will draw this diagram for NPN transistor. Okay, the first one is N region. It should come that the P should be comparatively small. Okay, this is P and this is N. So this is emitter, this part is base, and this part is collector. Now first you consider the junction 1, that is EB junction. Emitter and base junction, EB junction. So in that case, N, that is E, is heavily doped and base is lightly doped. So due to this reason, now you see, due to the heavy doping in case of N type, the size of that means very small part only included in the depletion region. And then in P side, it should be larger enough. In P side, it should be larger enough. Okay, so this will be the width of the depletion region, width of the depletion region. So in this case of EB junction, the depletion region will be narrow. Comparatively, it will be narrow. Comparatively, it will be narrow due to the heavily doping of emitter part. Okay, so the same thing when we come to this second junction. Who is the second junction? This part is the second junction. So this junction is named it as collector base junction. Collector base junction. So here you see this base is lightly doped and collector is moderately doped. So comparatively with the base, collector is having more charge carriers. So that what will happen? So in that case also, in collector part, very small amount of depletion region will be there, and in P side, that is base side, it will be like this. So comparatively, the size of this, I can once again I can draw this. Okay, so this size, by comparing this to J1 and J2, J1 is narrower, J2 is wider. J2 is wider. Why? Because due to the different doping level, that only you have to understand. Due to the different doping level, the width of the J1 and J2 is changing. Especially J1 will be always narrower and J2 will be always wider. Okay, the size will be bigger than the size of the depletion region in EB junction. So this is what you have to understand. So that we can say narrow emitter base depletion layer and then wider collector base depletion layer. So this is the 2 points you have to remember in case of BJT. This is the formation of depletion region. So this junction is there, no, J1, that is EB junction. It will act as input diode. Okay, so junction is nothing but a diode. So this EB junction act as the input diode as well as the CB junction act as the output diode. It will act as the output diode. Okay, so this main point what you have to remember, EB junction should be narrow and the collector base junction CB junction will be wider, comparatively wider, right? And then EB junction acts as the input diode and the CB junction act as the output diode. Okay, so next we are going to discuss about two junctions are there, how the biasing should be given. So in the previous case for a diode only two biasing, one is forward biasing and another one is reverse biasing, but already here two junctions are existing. So how the biasing will be changed, that part only we are going to discuss now. So now biasing of transistor, biasing of transistor, biasing of transistor. Why? Because two junctions are there. So the two junctions of this transistor can be biased in four different ways. Four different ways it can be biased. So by means of these four different ways, it will be used for four different applications. Okay, depends upon the biasing condition, its application will also be changed. This is what you have to understand. So if you change the biasing condition, accordingly the application of the transistor is also changed. So how it is changed and how the application part will be used, that part we are going to discuss now. Okay, so that two junctions are there. So the first junction, what is the first junction? Generally we mention it as J1. So the first junction will be EB junction. And what is that one? Second one, CB junction. CB junction, and which is represented by J2. And then if you according to the biasing of this two junction, how the operation will takes place? Region of operation. Region of operation. Okay, and the third one, if you connect these two junctions, different biasing, what is the application part? What is the application part? Okay, so this part only we are going to discuss now. So let us start one by one. So already I mentioned four ways we can connect. The first method, the first way is junction J1 is forward biased. Junction J1 is forward biased and junction J2 is reverse biased. So as you know well, forward junction means, listen, P type and the N type, P type should be connected to positive terminal of the battery and the N type is connected to negative terminal of the battery. This is forward biasing. Okay. So the first junction should be forward biased and the second junction is reverse biased. That is P is connected to the negative terminal of the battery and the N is connected to the positive terminal of the battery. This is the reverse biasing. So the first junction is forward biased, the second junction is reverse biased. So in that case, the region of operation is termed it as active region. Active region. So if we connect like that, this transistor will act as an amplifier, so that its application is amplification. It will act as the amplifier. Already I said it strengthens the weak signals. It strengthens the weak signal. So that is the function. Okay. And the second case, what is the second case? So second case, first junction is forward biased and the second junction also forward biased. Both the junctions are forward biased. In that case, the region of operation is termed it as saturation region. What is the name? Saturation region. So in that time, if we connect like this, how the transistor will react, how it will work? That will work as worked as a switch on position. Switch on. Switch will be on. Okay. And the third case is both are reverse biased. Both are reverse biased. In that case, it's the working, that means the region of operation is cutoff region. What is the name? Cutoff region. In that case, the switch will act as a off position. Switch will be off. Okay. So when we connect both the junction as reverse biasing. And the fourth one is, it should be the reverse of the first case. Okay, forward means reverse and the second one will be forward. Okay, this is the inverted position for the first case. That's what it is called, inverted region. What is the name? Inverted region. So in this case, actually this will be very rarely used. Rarely used case. In some digital circuits it is used. Rarely used in digital circuits. Okay. The main function of the transistor is amplification and switching. Amplification and switching. This is what you have to remember. Okay. So now we have discussed, if you give the different connection, different biasing for the junction, its operation is changing. Accordingly, its application is also changing. So this is what you have to remember. So in this video, we have discussed what is meant by BJT and what is the small introduction part for that. Okay. And then how can we define the BJT and what are the types of transistor and then how it is constructed. It contains the three regions: emitter, base, collector. Okay, individually we have discussed everything, and then formation of depletion region and then biasing the transistor. So I hope you understand these topics. So you just go through it. If you have any doubt, you can ask in the comment box. Okay, so thank you everyone.